Okay, first we're going to reserve some memory for its user-defined characters. So we change the memory and the variable's pointer to 26. That'll reserve us 512 bytes between 6656 to 7168. That's where our screen memory starts. Okay, then we're going to change the address to which the computer gets its character data from. By doing that, we have to change a VIC chip register 36869, and we're going to make it point to 6144. That's because we can only make it point in 1K jumps. You can make it point to address 0, address 1K, address 2K, 3K, 4K, 5K, 6K, 7K, and you can also make it jump point to 32, 33, 34, 35, 36, 37, 38, and 39. You can't actually make the start of the character data begin at any other places than those. So 6144, that's 512 bytes lower than the memory that we've reserved. But the way we get around this is we don't actually use any of those characters that are stored in the first 512 bytes. We'll only use the characters 512 bytes up. So each character uses 8 bytes, so if you divide 512 by 8 you get 64. So we'll start at character 64, and that should start at 6656, because we don't really want to go altering any memory lower than that because it'll screw up basic and variables. Okay, got a new variable here, v5. That's just stores the value in 36869 so we can restore it later. Okay, and CM, this is the value we're going to put in 36869. Okay, and there we go, poke 36869 CM. Right, fill the screen again. Well, fill these 1024 bytes, same as usual, but what we're doing is we're putting the value 64 in instead of like random characters or anything. So it's going to fill the screen with character 64. Then it's going to be R2 is 6, so that's going to be blue. Okay, so just fill the screen with that character. Right, next, here's where we load up the user-defined character. Right, each character is made of 8 bytes, 8 bits in a byte, and each bit represents a dot. So that's 8 by 8 bits. So that's what a character is made up of. So we're going to read in 8 bytes. So for C equals 007, that's as count. Read B, that's as byte. Poke 6656 plus the count with the data with the value that you've read from the data. Next C, so that just loads up 8 bytes with the values that we've got in the data statements. Okay, this is we've made the time delay a little bit longer. So there we go. Okay, 1000 to 1004. We just poke all the original values back into the VIC chip registers. And 2000, this is as character data. These are the bytes that we're putting into the character 64. Okay, I'll just run it and show what it does. There you go. A nice smiley face character that we've nice smiley user-defined character there. Right, and that's just about it. Just let the time delay tick down, and we could actually have 64 user-defined characters, but you need like 64 data statements if you're going to put 8 bytes in each data statement. But yeah, that's how you make your user-defined characters. Okay. Next video, I'm going to be talking about. We're going to be doing. I'm going to be doing the some more on the user-defined characters. But to be honest, I'm just going to make a pretty picture to show you on the next video. It's just a little bit of interest, and talk about an interesting fact about the size of the screen in PAL mode. Okay, right. Thank you very much. Thank you for watching. See you later.